here's the plan for today. So you've had graphs from limits, you've had graphs from limits from equations. So now we're going to talk about limits approaching a number. There are 4 strategies. We're going to list out all 4, and then we'll go through each category one at a time. So your first one is just going to be substitution. Second one is going to be factor, cancel, substitute. Third one is going to be simplify. And then you have special cases. And there are 2 of those. Okay, so we're going to start off with substitution. We'll do a couple of examples in each category to make sure you got it. And then if you want to mark it on your notes, this goes with homework 5. So the homework you got yesterday that you could really only do the front of, this is the notes that go with the rest of that homework. Okay, so number 1, we're going to do the limit as x approaches 2 of 4x plus 1 over 2x. Okay, so if your limit is approaching a value that you can plug in without getting it divided by 0, you just do that. So when I plug in 2 here, 2 times 2, I'm going to get 4 on bottom, then it's good to go. So plug it in on top and on bottom. I'll have 4 times 2 plus 1 on top. 2 times 2 on bottom. What are we going to get as our limit? Good. 5/4. Number 2, easy. Yes? You don't. Let's talk about why. The Bobo Bot and Betsy are when x is approaching what? Do you remember? Infinities. So if it's approaching a number, those are the type of limits we're looking at today.
How is 5?
Yeah, isn't that nice?
Shouldn't be 9.
Oh, yeah. Did someone say 5 or am I crazy?
Kane said 5.
Oh, Kane, you led me astray. Okay, that's supposed to be a 9. That doesn't even pretend. Now 4 times 2 is 4 plus 1 is 5.
It was a prank.
Happens to the best of us. Okay, next one. Limit approaching a half. Then we're going to have a quadratic, 4x squared minus 8x plus 5. So about half your AP test is going to be no calc. But these calculations shouldn't be too hard. We're going to take the 1/2. We're plugging it in here and here. When you square a fraction, you're just squaring the top and the bottom of the fraction. Okay, and you can choose not to show every step. If it's your notes and you know that you can skip from a half squared to a fourth, that's fine. But a half squared, you'd have 1 squared on top is 1, 2 squared on bottom is 4. So I have 4 times a fourth minus, okay, that's 1, good. So I'm going to write out 4 times a fourth minus what's half of 8 plus 5. I'm going to turn this into a 1 minus 4 plus 5. Close? 1 minus 4 is how many? Negative 3. Negative 3 plus 5 is 2. So your limit would be 2 for that one. Make sense? Yeah, I think combining. You were close. You were close. Okay, next one. X approaching pi fourths of cosecant x. Okay, so a little bit of trig coming back. So cosecant is whose partner? Cosecant goes with sine, so find the sine of pi fourths. And then remember, cosecant is that flipped. Okay, so I'm going to write over here the sine of pi fourths. Okay, so pi fourths is your middle finger. Center your fingers that go down, so you have 2 of them, so it's root 2 over 2. But then when I flip it, what am I going to put?
2 over root 2.
2 over root 2. Very good. So you're just taking that angle, plugging it in. You could simplify it if you want to not have a radical on the bottom, but AP test, you don't have to. Good? All right, number 4. We have the limit as x approaches pi sixth of sine 2x. So am I finding the sine of pi sixth?
2 times.
Yes, there's a 2 built in here. That's going to change the angle. So I'm going to plug it in first, and then we'll reduce it. So I really want the sine of 2 times pi sixth. Okay, if there's a 2 in there, you need to reduce this fraction down first, then do your trig on it. So pi 6 multiplied by 2, bless you, what do we get? Here, pi thirds, how many? Root 3 over 2. Very good. Oh wait, I just told you the wrong thing. Okay, so that'd be pi thirds, then you'd go to your hand, right? So it should be root 3 over 2. So it's sine of pi thirds, which is root 3 over 2. Bless you. Questions? No? Okay, one last, oops. Why did I try to label it number? It's Friday, it's okay. Okay, number 5, limit as x approaches pi thirds of x secant x. Okay, now remember, just like on the quadratic, if there are multiple x's, I'm just plugging that value into multiple places. So I'm going to find pi thirds times secant pi thirds. So you just have an extra little thing in front of your secant. So it's going to be pi thirds times the secant of pi thirds. Now, who's secant's partner? So we need to find the cosine of pi thirds, then we're going to flip it. Okay, cosine of pi thirds would be, before we flip, it'd be 1/2. Then flip it, it's a 2. Yeah? So my answer is 2? Nope. What am I missing? Remember that pi thirds was already out there. So my answer is 2 pi thirds. Going too fast or feeling okay? A little too fast? Okay. All right. When y'all are ready, we're going to move on to the second category, factor cancel. Need another minute? Good? Okay. Okay, so factor, cancel, substitute. That's our next category. Okay, first limit that we're going to look at is the limit as x approaches 0 of x squared minus 3x over 2x. Okay, so our first strategy is just to plug it in. So we end up with a problem. If I want to plug in 0 directly, okay, I get what on the bottom? 2 times 0 is 0, not allowed to divide by 0. You'd think, oh, the limit does not exist or whatever, right? Okay, if you can factor and cancel out the x, then that limit could actually really exist. So, looking at the top up here, what kind of factoring is that? Okay, yeah, we have an x in both terms, so that's a greatest common factor. So I'm going to take an x out to the front. What will be left over from the top once I pull that x out? X minus 3. Now, on the bottom, I had a 2x. So when I cancel, I can pull my x off the top with my x off the bottom, because any x divided by x is going to give me 1 because they're the same. Okay, so then you factor, you cancel, and then you substitute into what's left over. So I'm plugging a 0 in here. What's 0 minus 3? And then divide by 2. Good, so I have 0 minus 3 over 2, negative 3 halves, and you're done. Good? All right, number 2. We're doing the limit as x approaches 4 of x squared minus 16 over 4 minus x. Okay, so we already know it's factor cancel. So we have to look and see what part of that we can factor up here. Okay, it's not a greatest common factor. They don't have anything in common. What kind of factoring is it? They're both perfect squares. Square root of x squared is x. Square root of 16 is plus or minus 4. So we're going to put x plus 4 as one term, x minus 4 for the other term. Okay? So I have the limit as x approaches 4 of x plus 4 and x minus 4. Okay, question. As of right now, can these two 4 terms with the minus sign cross out with each other?
No.
No. We're going to have to make them look the same. How can I do that with this bottom one? What could I do? Huh? Yes. Okay, so instead of thinking like you're timesing by a negative 1, think about you're dividing a negative 1 out. Okay, here's what that's going to look like. So that says GCF divide by negative 1 out to the front of the denominator. So this is what I'm going to have now. On top, I'm still going to have x plus 4, x minus 4. But on the bottom, I'm going to pull a negative 1 out of that fraction. Now think about, if my x used to be a minus x, but I divide by a negative 1 to the front, what's the sign on my x now? Positive. And if my 4 used to be positive, but I'm dividing a negative 1 out, then now it's a negative 4. And then think about if I times that back in, it's still the same. I'm just pulling a negative 1 out so that I can cancel. So now I have an x minus 4 top and bottom. Those guys can go. Take your 4, substitute it into the remaining x in the equation. 4 plus 4 over negative 1, what do we get? Negative 8. Good job. So if it's almost the same term, just pull a negative out. You can make a match. Okay, next one, number 3. We have the limit as x approaches 2 of x cubed minus 4x over x minus 2. Okay, so the top is cubic. Okay, but if they both have an x, pull the x out. And then look at what's left over and see if you can factor it twice. So my first step, when I pull that x out, what am I going to be left over with?
X minus 4.
X and x squared minus 4. And then what can I do with that x squared minus 4? You can factor that, that's a perfect squares, into an x plus 2 and an x minus 2. Then one of those is going to take out the x minus 2 off the bottom. Make sense? Okay, so I was lazy and didn't put my little x approaching 2. Break it down one more time here. So it's x, x plus 2, x minus 2, x minus 2. And then these guys here can cross out. And remember, after you cross out, the point of that is you're plugging into the leftovers. So if I take this 2 and I plug it in here, what are we going to get? Yeah, it'd be 2 times 2 plus 2. That'd give me 4 times 2, which is 8. Not too bad? Alright, a couple more like that. Next one, limit. This time x is approaching a. If it was plus or minus infinity, you'd be doing Bobo, Bot, and Betsy. But if it's approaching a value, even if it's a letter taking the place of a value, your goal is to plug it in. You want to fix it and plug it in. I'm going to give you maybe like a minute. Okay, think about what you could do with that one. Any ideas? What could I do on top?
Pull out a 2.
Pull out a 2. What could you do on bottom?
Pull out the square.
Make it a perfect squares. Very good. So on top, pull the 2 out. On bottom, that'd switch up into an x plus a and an x minus a. And then you're going to plug your a in. So if I were to do it up here, you'd have 2x minus a, x plus a, x minus a. These guys cross out, just like you expect them to in factor cancel. And then when I plug my a in, something else should also cross out. What else is going to cross out? The 2. Because on the bottom, I'm putting an a here. What's a plus a? 2a. And so if I have 2 divided by 2a, is that the same as just a? 1 over a. Okay, you have to leave something on the top. So I would leave a 1 up there as a placeholder. My a is going to stick, but my 2 is crossed out because there is 1 top and bottom. Make sense? Good? Okay. All right. Next. Oh, wait, no. Same category. Dang, forgot. Okay, y'all know how to factor, I hope? Yes? Okay. How do y'all factor? Like if it was this. I'll write the next problem down. If it was x squared plus 9x plus 14, bless you, what would you do for that top? What methods did y'all come in knowing? What? Yeah, you're breaking it up into parentheses. Did y'all have McDaniel with the X thing? No. What did y'all do to factor these? Guess and check? Any method or not really? Yeah, we have to factor the top with ABC. Good. Okay, so do you know how to do it? I'm just wondering there's so many different ways. I'm going to show you my way. I don't care if you do it, but just to kind of give you an idea so we can all somewhat be on the same page. I would have this is what McDaniel does, which is why I teach it. It's because I have y'all after her sometimes. So AC, my A is a 1, my C is a 14. 1 times 14 is 14. On the bottom, in the basement, okay, she puts the B, which is 9. Then you would have to think about all of the partners that times to 14 and add to 9. So I'd say 1 times 14, but what does that add to? Not 9. What about 2 times 7? That adds to 9. Then you divide by x on both, and those are your factors. So it'd be x plus 2 and x plus 7. Okay, now obviously that one's super easy, but when they get to harder ones, having somewhat of a method kind of helps. Okay? So on top, you have x plus 2, x plus 7. Okay? From there, what can happen? Cross those guys out. Plug in negative 2. We get 5. Good. So you'd have negative 2 plus 7, which is 5. Remember, ultimate goal, though, is to plug in whatever that number is. Okay, one more like that. Number, that was 5. This is 6. Limit as x approaches 3 of x squared minus 2x plus 8 over x minus 3. Okay, look at the top. I'm going to show you that same x method again. You can do whatever you want if you already know how to do it. Okay, so I put A times C at the top because that's your air conditioner. Okay, so 1 times 8 is 8. In the basement is a negative 2. Or, yeah. Okay, then what are my factors for 8?
2 and 8.
1 times 8 or 2 times 4. Do any of those give me negative 2 when I add them? Now, when I subtract them, I can get 2. But when I add them, can I get 2? No. So this is prime. Now, you might be thinking, well, why can't I make the 4 negative and then 2 minus 4 is negative 2? That's not going to work because what's the sign on 8? It's a positive 8. That means these have to both be negative, but then negative 2 and negative 4 give me negative 6. So the top of this is prime. What that means is that you can't fix that limit. That limit is not fixable. Then what is it? DNE. Very good. Okay, now we're going to make a little note about the difference. If a limit is fixable, meaning that the problem term cancels. Then limit exists because the graph has a hole. And think about, at a hole, you're going to still have a limit coming in, just that one dot is empty. Versus, you should have learned this in Algebra 2, hopefully again in pre-calc, that if that doesn't cancel, what happens in the graph? You get an asymptote. And so it goes to either infinity or negative infinity, which means it does not exist. So we're going to put here, if the limit is not fixable, it does not exist because the graph has a vertical asymptote. At that value. So if they cross out, you have a hole, you have a limit. If they don't cross out, then the limit doesn't exist, but it's because graphically you have an asymptote at that point. Okay? Okay, next one. Limit x approaching negative 4 of 4x squared plus 17x plus 4 over x plus 4. Okay, so whatever factoring method you want, can I remove the 4 by doing a GCF? No, the 17 kind of messes that plan up. If that could work, we'd do it because it's easier. Okay, so I'm going to show you the x method one more time, just in case you don't know how to factor this without. So you're going to put your AC at the top. That's your air conditioner. What is A4 times C4? 16. On the bottom, I'm going to put 17 in the basement because that's my B. Okay, what are my factors for 16? Okay, 1 times 16, 2 times 8, or 4 times 4. Now, because I need them to add to give me 17, who am I going to pick?
1 and 16.
1 and 16, but this is where this method comes in really handy. If I want a 4x squared in the front, you're going to reduce these both over 4x. This is what I mean by that. Okay, you're going to put over 4x, and then see if either one of those can reduce. Can 1 reduce by 4?
No.
No. Can 16?
Yes.
What's 16 divided by 4?
4.
4 over x. And then your factors are 4x plus 1 and x plus 4. 4x plus 1 and x plus 4. Does that make sense? Now, the other way that I think Miss Grissom does is she'll make you think about, is it a 4x and a 1x, or is it a 2x and a 2x, and you have to try a bunch of different pairs. That works too, it just can take longer. But if you hate the x, doesn't hurt my feelings, don't care. Okay, so now that we're here, however you factored it, what are we canceling out? Plus 4s, then we're plugging in a negative 4. So those guys are gone. Negative 15, good. So we have 4 times minus 4, which is negative 16, plus 1 is negative 15. Good? Okay. We have 2 more in this section. 2 more. Yeah, this is the longest one. Easily the longest one. Okay. May I turn the page? Are we good? Some of you don't look good. Are you sure? You can say no. Just wait a minute if you need it. No? Okay. All right, 2 more left in this section. Next one, you're going to have number 8 is the limit of x cubed minus 2x squared plus 3x minus 6 over x minus 2. Yes, yes. My other class said they'd never even seen that before. Okay, so the other class that I asked, I was like, what do you do? And they were like, long division. And I was like, that would work, but that's way harder than factoring by grouping. Do y'all remember that?
Yeah.
Okay, so grouping, you put them together in partners. So my first 2 are partners, my second 2 are partners, and then I'm going to see what they have in common. So out of the first 2, what do they share? And x squared. What's left over?
X minus 2.
X minus 2. Second 2, what do they have in common? 3. What's left over? X minus 2. Okay, if this guy, the leftovers, if those match each other, then I have a greatest common factor. They both have an x minus 2. So you're going to pull that to the outside, and x squared and plus 3, they'll get to be partners. So that's factor by grouping. Okay, so my x minus 2 is going to come to the front because they both had one. And then x squared plus 3 gets to be in its own parentheses. That is called factor by grouping. Okay? Then from there you can cross these guys out. X squared plus 3 is all left over. I have limit as x approaches 2. What are we doing from there? Plug in. 2 squared is how many? 4. 4 plus 3 is 7. Good. Okay, the last one. Okay, limit. X is approaching negative 3 of x cubed plus 6x squared plus 9x over x plus 3. Okay, so last time that we had a cubic, we had to do grouping, but you need 4 terms to be able to do grouping. So grouping is not going to work here because I only have 3 terms. What combination of factoring could we do? First, we're going to pull the x out, GCF. Then we're going to have a quadratic that you can break up into a binomial. Okay? So first, we're going to take the x out. That's going to give me this. And then from there, I want you to factor that top part. You can do it by the AC thing with the little x, or just do it on your own. You need numbers that multiply to what at the top? 9. They need to add to 6. Who are my partners? 3 and 3. Now look at the front. If there's a number here, I have to reduce, like when it was a 4x squared. But if it's a regular x, put them both over x, those are your factors. X plus 3 and then x plus 3 again. So I'm going to have the limit as x approaches minus 3 of x times x plus 3 times x plus 3 again over another x plus 3. Can all of the x plus 3's cross out? Nope. How many of them can cross out? Only 2. One off the top, one off the bottom. Okay, so that guy's gone. 2 are still left. Plug in your negative 3. I have negative 3 on the outside times negative 3 plus 3. What's that term in the middle? That's 0. And negative 3 times 0 is 0. Good job. Got it? Okay. Your next section is simplify. There's only 3 examples. Okay. Okay, I'm going to turn the page here in a second. It's going to involve some conjugates. Do you remember conjugates? Maybe. We'll see. Okay, so simplify up here at the top. We are going to have the limit as x approaches, what was it, 4 of x minus 4 over root x minus 2. Okay, so take a look. The problem is if I plug in 4, I have root 4, that's 2. 2 minus 2 is 0, not going to work. So the limit might not exist, or it might be fixable using conjugates. So if this is my original, what is the conjugate? Remember? Close. You just take the minus and you switch it to a plus. So if this is a minus version, we're going to put the plus version. So put that on bottom. If I put it on bottom, I have to also put it on top. So I'm going to put a root x plus 2 on top and a root x plus 2 on bottom. Now, on the top, do not factor it out or times it out. So we're going to leave this as x minus 4 root x plus 2. Leave that alone. On the bottom, though, we're going to times it out. We're going to go one term at a time. So for my first one, I'm going to do root x times root x. What am I going to get for root x times root x again?
X.
Regular x. Put it right there. Okay, next term. I have root x times plus 2. Plus 2 root x, right? So I have a regular x first. Then I have a positive 2 root x. Okay, moving to the next term. So now we're down here, we're using our minus 2 times root x. That's a negative 2 root x. And then what's negative 2 times 2? Negative 4. Very good. Then, huh? Basically, yeah. And then these two guys in the middle, remember the point of a conjugate is that your root x is in the middle, cross out. One of them's a plus 2 root x, one of them's a minus 2 root x. Those go to 0. And on the bottom now, I only have an x minus 4. What did I have on the top? An x minus 4. That's where my cancel's going to happen. So I have an x minus 4, x plus 2, and another x minus 4. So the conjugate fixed the bottom to where it matches the top and they can cross out. So slash those guys out. Now can I plug in 4 without a problem? Yes. So I'm taking my 4, I'm plugging it in here. I have the root of 4 plus 2. What's the root of 4? 2. 2 plus 2 is 4 for your answer.
And it doesn't have to be plus or minus.
It doesn't have to be plus or minus because the root was already there. Okay? Alright, we have one more conjugate. Okay, this one is going to be limit x approach 3 of root x minus root 3 over x minus 3. Okay, I want you to try it on your own. You're going to multiply by the conjugate of the top. Here's why. If I multiply by the conjugate of the bottom, I'm going to get x squared minus 9. Is that on top to cancel out? No, then that's not going to fix the problem. So take the top. What will my conjugate be?
Root
X plus root 3. Put it here and here. Okay, you're going to times out the top. Don't times out the bottom because you want stuff to cancel down there. So I'm going to put a root x plus root 3, top and bottom. Okay, but the bottom, you're going to leave it alone. Don't change the bottom, only times out the top. Okay, on top, root x times root x. Regular x, very good. Write it down. Next one, root x times root 3. Root 3x. So I have regular x plus root 3x. Now, could you leave the root 3 and the root x each in their own roots? Sure. Doesn't matter. You can leave them separately, put them together. It doesn't make a difference. Okay, now we're on the minus 3. Minus 3 times root x is minus root 3x. Good. And then last one, minus root 3 times root 3 is minus root 9. What's the root of 9 though? 3. Then my middle two terms there are going to eliminate each other. So this one's gone, that one's gone. I have an x minus 3 left over. I have an x minus 3 on the bottom. Those guys are going to cancel. Okay? So I'm going to kind of cross out all of the top with that. So I have root 3 plus root 3. How many root 3's do I have then? Root 3 plus root 3 is 2 root 3. Is that the answer? Under a 1. Very good. Remember that if you leave this top blank, that's not going to work. So you have to put a 1 over and a 1 over. Then remember, you don't have to rationalize the denominator. Not required. Okay? Alright, one more like that. Okay, limit x approaching 0 of tan x over sine x. Tan x over sine x. Okay, so tan is the same as what? Sine over cosine, so I'm going to rewrite my limit as sine x over cosine x. And then for my sine x on bottom, I'm going to put it over 1 so they're both fractions. So I have sine over cosine on top, divided by regular sine on bottom, which is really sine over 1. Then remember, when you're dividing fractions, what do?
Multiply by the reciprocal.
Multiply by the bottom's reciprocal. So I'm going to have sine over cosine multiplied by, flip it, what's going to happen?
Multiply by 1 over sine.
Yeah, and the signs are going to cancel. Good. So it's sine x over cosine x times 1 over sine x. Those guys are gone. And so remember, even though the sine of 0 is 0, once I cancel it off the bottom, that kind of fixes my problem, right? Then I plug in 0 to cosine. Okay, 0 is here. Cosine are my top fingers. Square root of 4 over 2, which is 2 over 2, which is 1. So I have 1 divided by 1, which is 1. Make sense? Okay, Last one, you have two special limits. We're going to write them down, but they're super easy. Super easy. Okay, the first one, am I good to turn my page? You can say no.
Are we doing more examples?
We're going to do one example of each one. So you have two rules, two examples. Okay, so your special case. This is item 4 on your original list, if you like the Roman numerals. Okay, first one is the limit as x approaches 0 of sine ax over bx goes to a over b. Second one, limit as x approaches 0 of 1 minus cosine x over x, and it goes to 0. Okay, we all have like 2 minutes, so do we want to just do those examples next time? Okay, promise you won't forget? Do you promise? Okay. Alright, well you have the whole weekend to try not to forget. So we'll do those next time. Write them down, and then the bell rings in like a minute. Make sure if you didn't give me your homework, do by the end of the day.
Go.
Good job! You still want to try to go to your car? Okay.
Oh, my leg. I like noodle bro. I did ball balls yesterday.
I don't get very
Not fun today. That's a random point. Oh, thank you.
You should have, I think, gotten it the day before. Oh, wait, the extra one I passed out. Walk fast, you can do it.
Why not now?
Here. Jeremy. And then the notes for yesterday only go with the top half of that. All the rest of it are going to have to be today. Y'all have a good weekend!
Usually like it's like 2 to 4 outside, 6 and 8. Trash. I was just saying all this. I can't.
Have a good weekend. Yep, can't wait. Have a good weekend. Okay, if